In an earlier tutorial, we described the process for putting a measuring aperture on a target that is very, very difficult to see using astrometry.net to get a world coordinate system calibration for a frame. That's a procedure that maps right ascension and declination coordinates to the XY coordinates of your image. Now, it turns out that astrometry.net requires a minimum field of view of around 15 arcminutes, and many of the videos are taken of occultations with camera setups that have narrower fields of view than that. So we've built into PyMovie what we call a manual WCS calibration. The idea behind this scheme is that if we can locate two stars in the star field that have known right ascension declination coordinates, we can use those to calibrate a frame and thus find and place an aperture on an otherwise very hard to see target. I'm going to demonstrate that here. I'm going to open a folder that has a pretty good star field. I happen to know that the target is somewhere in here, but I would like to locate it precisely. So I'm going to choose a star that is close to where I expect our target is. I'm going to add a static aperture, and I'm going to name it after the UCAC4 designation for that star. Finally, I'll enable jogging and position our aperture precisely on what appears to be the centroid of that star. Disable jogging, and I will repeat that process on another star that's far away, about as far away as we can reasonably get from the first reference that we placed. So once again, I'll add a static aperture. I will name it after its UCAC4 designation. Sorry for the fumbling. So that's what we're going to call with star. I'm going to enable jogging and position more closely to the center, the centroid. I'm going to disable jogging. Now I'm going to start this process of manual WCS calibration. Just as with the astrometry.net calibration, if your pixels are not square, you need to enter the proper pixel height and pixel width, because that has to be taken into account in this calibration as well. It turns out that this camera was a Watt 910, I believe, and these are the correct pixel sizes in microns for that camera. So I will begin the calibration by clicking this button. If we look down here, it says what's happened. You need to keep looking down here as you go through this process. So we need to place aperture 1 and assign it the correct right ascension declination coordinates. So let me activate this aperture. I'm going to pick out the correct name and copy it. I'm then going to paste that into this box where we can go to Vizier and find out what the correct coordinates are in right ascension declination. Once I have that in that box, I can transfer that to the aperture by clicking here. So reference 1 star has been recorded. We now need to repeat that for aperture 2. So I'll activate aperture 2 by putting my cursor briefly into the aperture. I will do a copy, a paste, another query. I'll move that coordinate information into the aperture, and now it's time to set the target location. So the target is star 672-034710. I'll query Vizier and then click Set as Target, and there is the aperture placed for us. I'm going to get rid of this one just so it's a little easier to see what has happened here. And we can see that in fact, now I know it's dim, we'll change the contrast in a moment, but we've managed to set our aperture right on the pixel of the target. There it is. There's our target. And that completes this video.